So in this question, we have a position time graph, so we want to do our Oizerga. Our origin 0, 0. Y-axis is position, x-axis is time. So, of course, we can read anything about position and time. The gradient's delta x over delta t, which is the velocity, and the area is meaningless in a position time graph. So in studying these, we might see that this one looks like it has a slope to that point, and then the slope changes. And then in the second graph, we have a particular slope, and it obviously goes to 0. So we might even notate that, v equals 0. And here we have v equals something, and this v, it increases. All right, so the position of two identical carts on a horizontal track. Which one about the magnitude, the momentum of the two cart system's center of mass is true? They're two identical carts, which means they have the same mass. So the position then, in the beginning, would be located there, the midpoint. Here it would be the midpoint. Here it would be the midpoint. Here it would be the midpoint. There it would be the midpoint. And there it would be the midpoint. And so those are the positions. And so here we see velocity is equal. In fact, all three of these have the same velocity because they have the same slope. This one has a velocity equal to 0, as we said. This one has an increased velocity, and this is an intermediate velocity. So, if the center of mass is the center of mass, we're really talking about what's happening to the velocity. The momentum of the center of mass is constant from t0 to t5. Well, if the momentum is mv, the mass stays the same, but the velocity does not. So therefore, that's false. Momentum of the center of mass is smaller after t equals 2 seconds than before t equals 2 seconds. Well, p equals mv, and the velocity is the slope, and the velocity is lower after 2 seconds. So it looks like this is the answer, but we'll check. Is larger after 2 seconds? No, that would need a steeper slope. So C is out. Those center of mass increases at a constant rate from t0 to t5 seconds. And that's definitely not the case, because there is this P equals mv value. And we could write it as P equals mv, where it's P is m times the slope. And then afterward, P equals mv, and it's P equals m times the slope. And the slope is less. It's constant during this interval, constant during this interval. It changes abruptly at time 2. So that's why the correct answer is choice B.